Gases. Gases are a type of state of matter where gases do not have a definitive shape. Particles are so far apart and they move so fast, which is one of the physical properties of gases. Units that are related to gases. Pressure, which is a force. There's different units that we use for pressure. 1 atm equals 760 torr, which equals 760 millimeters of mercury, which equals 101.3 kPa. These millimeters of mercury, kPa, torr, and atmospheres are all pressure units. Volume is related to space, and we usually use milliliters or liters when measuring volumes of gases. So there's 1,000 milliliters equal 1 liter of gas. Temperature is a measure of kinetic energy, or how quickly these gas molecules are moving, and the higher the temperature, the faster they're moving. But we measure temperature in either degrees Celsius or Kelvin. We need to use the Kelvin scale in order to measure gases' temperature because we need to have numbers that are above zero. So the way we convert degrees Celsius into Kelvin is we add the number 273. N stands for moles, or how many gas particles are in your sample, and moles can be calculated using the mass divided by molar mass. Gas laws. Here's our generic equation. P1 times V1 over T1 equals P2 times V2 divided by T2 over N2. And we use this equation when solving for different problems. And we always cross out the ones that are not mentioned or the ones that are constant in the problem. So Boyle's law relates pressure and volume, and pressure is indirectly related to volume. This is the only one that's different. Okay? Charles' law is the direct relationship between volume and temperature, which means as volume goes up, temperature goes up. Avogadro's law states that volume and number of moles are directly related, so the number of moles increases, the volume increases. And Lusak's law states that pressure and temperature are directly related, whereas pressure goes up, temperature goes up as well. The ideal gas law is a perfect state, where the gases don't exert attractive forces on other particles. We use P, V equals nRT to solve for these ideal gas law, or the ideal gas law variables. P, remember, is pressure. It can be either atm or kilopascals. V is volume, has to be in liters. N is in moles. R is the gas law constant, where if you're using atms, you use 0.081, or in kilopascals, you use 8.31. And temperature, again, is in Kelvin. STP stands for standard temperature and pressure, and remember the standard conditions is 1 atmosphere, which is the standard pressure, and the standard temperature is 0 degrees Celsius. Remember, 1 mole of any gas at STP has a volume of 22.4 liters. Dalton's law of partial pressure relates to the fact that the total pressure of a gas mixture equals the sum of all the partial pressures of all those gases within the mixture. Here's our equation. The total pressure equals the partial pressure of gas 1 plus partial pressure of gas 2 plus partial pressure of the nth number of gases. If we're going to solve for partial pressures, remember P equals nRT, P equals N times R times T divided by V. So here is our equation if we're given R, T, and N values. We can also relate that the N total equals the number of moles for each partial or each gas within that mixture. So this N total is going to go right there. Sometimes you can use mole percentages to get partial pressures because the pressure is related to the number of moles. So you can get percentages. Once you get percentages, you apply those percentages to the total pressure to get the partial pressure of each gas. Final thing we talked about was gas stoich, and here is the roadmap what you have and what you want and the different pathways to get there, you always need the ratio, which comes from the balanced equation in order to solve. A couple things about gases. We're going to use P equals nRT here, or at STP, we're going to use 22.4 liters as conversion factors. Okay, but any one of these places, so gases or grams, liters at STP. If I'm given pressure, volume, and temperature, I'm going to start here. Or if I have particles, I can start there. And any one of those places, grams, liters, P equals nRT, or particles are ending points when you're trying to convert one thing to the other using stoichiometry.